Good morning, and thank you for joining us today for our Total Quality webinar presented by Key Performance and Dassault Systems, featuring Innovia and Exelead. Today, we will explore how to transform quality management into your competitive advantage and improve product quality throughout the product development lifecycle. Speaking today, we have Garth Coleman from Innovia and Stefan Urban from Exelead.
All right, thank you everyone for joining. This is being recorded, by the way, so if people are going to join late, that's okay. We got a lot of information to share with you, and we're working from home still. Wherever you are, welcome. Welcome to my home office, and Stefan will be joining and giving some of his expertise. Hopefully we don't have any crazy glitches that may happen. I've got several monitors and things I'm trying to control. This will be fun. So we're going to start this, and the alternate title for this, to keep it short, is something that we say achieving total quality management. So we'll explain what that means, and hopefully by the end of this, you'll see what does it mean to have total quality management versus just regular quality management. So let me get everything working. Find my mouse here. All right, so I think you guys are on this call because something resonated in the invitation, something about quality. Well, LNS did some research last year and asked the question, hey, what kind of challenges do people have when you're trying to achieve your quality objectives? And these were some of the responses that were there. You see the order of responses. Okay, lack of executive support, I think, is common for any project you're trying to do, but I think that the first three there are very interesting. You know, this fact that quality is often its separate silo, and a group trying their best to kind of intermingle with everything, and all this disparate data, and trying to finagle it all together, trying to analyze the metrics, the KPIs, and it's not really on everyone's mind to be responsible for quality. And then, okay, there's some visibility stuff, but then you get into the process of quality, the governance of quality. Is there a process for continuous improvement? Is there a process to capture non-conformances or issues as they arise? Or is it all just ad hoc? And you're doing your best, you got some paperwork, and the QA guy's running around trying to keep ISO compliancy, that kind of stuff. You know, I had that job. I know what it's like. So this is really an interesting survey, but I thought, given that you guys are on this call right now and something is resonating on quality, I thought I would take some of these responses and push this to you guys, and I'd like to know what you think. What is your challenge? Now I can only put 5, so I kind of picked these 5. Which one is kind of top of mind for you guys? Now, if you're running full screen, I think you got to change it to like not full screen to enter the poll, but hopefully you guys can put a poll, and that just helps Stefan and I make sure we're tailoring our speech accordingly. So I'll give you a little bit to answer this. You know, again, the idea being that you know, when you don't have the data or the ability to access it or measure it because it's a department and trying to finagle everything together without the process, or is there engineering? You know, is there some things engineering is not getting visibility to with respect to quality because, again, it's a different department. So I'll just give another few seconds here for this poll. I see some stuff coming in now. And hopefully you're starting to get a sense of, with this survey, with this poll, kind of what we're starting to get at, which hopefully is the stuff you're trying to get at. Right? Votes are still coming in. This is very interesting. I can see the preliminary. I'll put the results up in a second. I know Stefan is probably anxiously awaiting these. Very, very interesting. So if you remember, on the slide I was showing, disparate quality systems and data sources and quality metrics and the department not responsibility were the top 3. And so far, all right, most people have voted. I'm gonna just close the poll now. Sorry if you couldn't get in there. And let me share the results on this. This is what you guys said. So pretty much the same top 3 are the same top 3. So it looks like people have some processes, generally speaking, or that's maybe not the top of mind. But the top of mind is just the fact that there's different things to try to connect the dots with come to quality. So again, this is what we're getting at with the idea of total quality management. So Let me close that poll. So thank you for that. That's make sure we do have the right information for you. The top 3 things, actually these top 5 things we're going to be talking about. Now let me go back to the deck. You can see me on the screen. All right, so this gets into really the crux of the matter, which I hope is obvious to everyone. I don't think what I'm going to say here is anything earth-shattering, but just to put the right context in place is, when you want to deal with quality, there is some trade-offs to be made, right? Because there's a cost, and the cost is how much does it cost to have good quality, but then what is the cost if I don't do that and I have poor quality? And that's the total cost that needs to be considered. And when you think about that, obviously the good quality comes in the early phases: design, engineering, manufacturing, making sure you've got whatever you're doing to validate and follow the right processes, versus the preventative things that you do before things get out the door. There's a cost to that, obviously. Of course, once it's out the door, now there's a cost to deal with that, with the non-conformances, failures, warranties, all that kind of stuff, and bringing that back in. By the way, there's these other costs of things like whether it's liability, litigation, whether it's brand reputation. That's really hard to measure, but that can be a big one. The word of mouth, you got some bad stuff out there, that can be really, really hard to recover from. So that's kind of the obvious thing. And again, disparate systems, how do you try to be holistic to deal with all these different elements and all these different departments and disciplines? Now, as I said, it's a trade-off, right? If you want to have fewer failures, it's going to cost you more to do all that appraisal and prevention. So there is a trade-off point that everyone tries to manage. And by the way, those curves may be different, right? This is kind of showing the hockey stick at the end, but depending what systems you have and how you're managing it, that hockey stick cost could be early, could be really expensive just because the system isn't there. But ultimately, there is some kind of calculus to be done here. And then, of course, there's leeway, right? Some degree of failure can be acceptable depending on the industry. Clearly, if it's fashion and there's a little failure, a rip or something, that is a lower cost to deal with than, say, an aircraft failure, right? That can be catastrophic. Delays on the thing, people complaining, they're complaining on social media, I'm stuck in the plane for 6 hours, or God forbid, there's a horrific accident. And same thing with anything dealing with people, right? Pharma, med devices. This is the whole challenge with you don't want to really have stuff there. That's like livelihood in there. So that's the trade-off that needs to be done. And then, of course, failures to do that results in litigation and so on. But there's a cost involved, and there's a buried cost that's understood, whether it's good or bad quality. There's cost here, and it's significant. Depending on the industry, depending on what's going on, it can be almost 8–10%, just kind of baked into the cost. So whatever we can do to lower that is going to really help that bottom line. Now, that's the challenges here with respect to now dealing with quality. Obviously, when something gets out the door, people want it fixed now. I've got an equipment in the field, it's not working, come fix it. So there's an extreme cost to fix these things later versus doing that more proactively up front. Obviously there's a cost, but it's not as impactful in that cost. So trying to deal with things earlier makes sense because there's a cost there. Of course, there's the other challenge with respect to the number of people impacted. If it's a design thing or manufacturing thing, okay, there's a couple things on the floor to fix. But if that thing goes out and you got thousands or millions of them out there, now you could be really in trouble because of the number of people that now are impacted by that poor quality that escaped. And then, of course, when it does escape, now you got to deal with it. Is it a recall, a warranty, a maintenance, or some other crazy consequence like some, litigation, all this kind of stuff, or just the fact that now we got to do a recall on everything. Oops, right? So these are huge costs that maybe are even unexpected. So this is really where we're trying to deal with, obviously not having the quality escape, but when things do happen, how quickly can you react and deal with that quality, and then also have a continuous improvement so it doesn't happen again. And then I'm going to show you how we can go even further to do right first time. So these are all the elements that we want to cover. But when you look at this challenge of being in operations and after sales, where the massive amounts of costs are, it makes sense that companies invest in big data and IoT to look at all this information and collect it all. Why? So they can kind of detect what's happening. Can we detect if there is an imminent failure and try to catch it before it goes, right? so that I can say, oh, before this goes down, let's deal with something, and tie that into some maybe proactive maintenance or optimized maintenance schedules. So we're not maintaining vehicles just to maintain them, but we're going to do it in a more predictive schedule, that kind of thing. So the big data, it makes sense that you do that to deal with those things. And then also, of course, trying to be aware of what's going on with customers and dealing with the complaints and trying to connect the dots on some of that data. But all of this is reactive, right? So the big data is great, it's in critical need, but it's not leveraged back into solving the quality problem in the first place. So big data and IoT are critical, but they're not doing effective continuous improvement. So what we're looking at, when you look at these quality events, non-quality events, all these different things, there's these signals, these issues that come up. And of course, you go into the investigation, you react, you say, what is the root cause here? What's going on? And then you try to recover and correct it, and then you talk about how I'm going to fix that issue, because it's escaped. And you're trying to minimize this time and cost to resolve that, and that's where the big data analytics can really support that. But when you think about why did the quality problem happen? Was it a design issue? Was it a materials issue, a manufacturing issue? Is there something that is going on there to investigate? And to do that, you've got to bring in other disciplines. You've got to understand the nature of maybe the more technical elements of what's going on. And that requires a lot of back and forth across systems and so on, so that ultimately you can take a decision. What are you going to do about it? Or is it just a one-off thing and no big deal? Or do we have a more deeper problem here that we now need to get into proactive quality to make it better the next time? And that could then resolve in, by the way, what can we do to inform design so that up front we never had the problem in the first place? How do we go and try to make it right first time? Which not only includes the physical characteristics and the performance characteristics, but the behavior and the experience characteristics. And this is really where we come in at Dassault, because our legacy is in the design world. We have all the science and the technology and the experience in generating and helping companies create products that excel in every industry. You woke up this morning, you did some things in the house, you took some devices, you cooked some things, you opened the fridge, you put some shampoo in your hair, whatever. Many of those companies are our customers using our stuff to deliver those products to you. Now, if you got in your car and drove to the office, which maybe some people aren't doing that yet, again, probably using some customer of ours doing that. So the reality is, if we can move closer to the design and leverage that in this quality context, this is something that we're able to achieve. And as I said, we've got this legacy that it's not just the design. We've had that for years and years and years. But being able to bring that forward into not only product lifecycle management, but this thing we have called the 3D Experience Platform, which starts to connect all of these elements. And actually, we're moving into the next phase, which is about people, because dealing with people and having this kind of a knowledge about people and being able to do therapeutics and things like that, that's our next evolution. And in fact, just so you know, a lot of companies right now that are doing the clinical trials for this COVID vaccine, quite a few of them are using Dassault Systems technology to do that. So we're in all these industries helping in so many different areas. And what's really important with this is that we have this thing called the twin. And our twin is a virtual twin. And of course, why do you have a twin? Because you need to connect it and bridge the gap with the real. And our belief is that we use that virtual world to improve the real world, to help extend it, to understand it, to make it better. And what we do in that twin, of course, is do all the experimentation, we do all the invention, we do all the exploration of that, and then use that to optimize what that experience is going to be. But as we talked about, things being in operation, we can return that loop back to learn from that usage and bring that enrichment back to improve the design. And we have processes we'll talk about, and you'll see how that works. But there's one significant advantage that we do in our twin, which we actually call the 3D Experience Twin. Because this takes time, and you have to let things escape to learn from. But with our platform, we can actually start to do all of that here in virtual. So we can virtually simulate the experience and check failure modes and so on right there in the twin. So I want to show you an example of that, because this is really a differentiating element that makes you a chance to first time right. Of course, we have all the quality systems. We're going to talk about those and how we manage that and bring the analytics and the IoT and the big data and reactive and all these things. But the ultimate goal here is this. And let me just, I'm going to push this video. So what you see here is a a drone that's put into the platform, and it's not just the geometry. Of course, it's got all the systems, the engineering, the systems that are behaviors, the simulations, and it has onboard sensors that are virtual sensors, and we can put that into an environment with its behaviors, and in this case, do a virtual flight test. But with all the onboard sensors, onboard cameras, all these things that you would normally get from a real test, we can do this virtually. So we can check the performance characteristics for all the things you want to measure, tied to whatever the experience and the requirements and the performance characteristics you want to validate. And by taking all of these systems and performance things on board, you can start to get that view. But not just on one, but now you can do that across all your different design variations that you want to do and test them on that same flight with the different performance, and then get all of the information so you can start to decide which ones are meeting the overall design, the overall characteristics you want to deliver, which ones are delivering on the requirements, whether they're the strategic requirements, whether they're specific customer needs, and then using that to drive how you want to provide configurability into your products that are tied to the rules and the technology and the performance characteristics that you want to have. So you're building out your portfolio plan based on all this and bringing your products to market with having the chance, best chance to be first time right, because you've done all of this validation, and it's tied to your company strategy, it's tied to the requirements that you're delivering, and all of the data is there. And this is not just the shell of the aircraft, it's every single system, every single piece of information there. So all of it is incredibly realistic because all of the information, the characteristics, the data, the weight, the attribute data, everything is there to take action on. So you have this virtual twin that is tied to the environment. You have everything there to then leverage, but then you're connecting it to the rest of the activities. So maybe you want to do some kind of 3D printing and you want to do some analysis to get the optimal shape that you want to leverage. You want to do some additional exploration on the design. You have the capabilities to do that sort of stuff. You want to do the trade-offs. Which way should I manufacture this for the best cost but still achieve my quality? Then use that to program your robots, whether you're 3D printing, whether you're machining, whether you're doing robotics, tying all these things in so that everything is connected. So your original plan, your quality you're trying to deliver, the experience you're trying to do is connected everywhere because it's one platform to drive all of these activities. Because when there's a change, you can then trace that change, track it, make sure it gets implemented everywhere. And that change can be for whatever reason. To resolve a quality issue, because you want to bring something new to market, whatever that change might be, you're able to connect everyone and continuously simulate and optimize that. So that, we believe, is a critical differentiator when we look at total quality management, because we can bring that science platform, this model-based modeling and simulation, to really bring the engineering into this quality discussion. Because if engineering is disconnected and it becomes reactive, you're always firefighting, you're always playing catch up. But if engineering can take these advantages to look at all this technology and do that, not just in the design, but also in the manufacturing process and how you manufacture and so on, you're able to do that. But then layering in the data science, the big data, on top of not only all this data that's in the platform, but all the other data sources that you have to bring that together so you can be much more data driven. But then because of the twin, being able to contextualize that data so that people can understand what it is that's going on and make the connections to the real products that you're delivering. And then ultimately being able to take action on that through extreme collaboration that we unlock across all the disciplines. So these four pillars, if you will, is where everyone is now connected, everyone is represented with understanding the data so that they can collaborate around that. All the efforts they do can be traced. And just realized my webcam is not showing. And they're able to decide what to do, and then have the execution ability to go ahead and take those decisions, track them, trace them, and learn them. And then that data is there for the machine learning and AI to use for the next go round. And you build up this kind of knowledge, know-how library for continuous improvement. And that's really what we're doing with the 3D Experience platform, being able to unlock this collaboration across all the departments so that everyone can now improve quality, improve innovation, be more proactive than reactive, being able to take all this and be extremely productive because everything is in the right place. Everything has the right context. There's no confusion. There's no lost time. There's no wasted effort. You minimize the errors because people are fully connected in what's going on. There's no synchronization to deal with where you can have errors. And that's going to massively increase speed. not just in overall time to market, but in time to quality. So now you don't have to make that trade-off of, you know, better, faster, cheaper. You can kind of get all three. You can be better and faster with a better economy there. That leads to the agility, meaning you need to make a change, capitalize on a market opportunity, or fix a misunderstanding that's out there. You have the ability to take those actions and implement those with complete visibility for everyone to what they're doing, so that they have complete alignment across the board, across all these disciplines. So getting all these pieces is what's going to bring that total quality management. And the monitoring piece, all the data, understanding it, taking advantage of it is an important part of that piece. Being able to have execution against that. So at the point of failure, being able to capture that and put that into the system. Then deciding what to do. You want to have this reactive quality. So you've got this very quick way to deal with that, but in a systematic way that's still being captured, because in some cases you need to go to continuous improvement with proactive quality. So this is where I'm going to bring in Stefan. He's going to walk you through kind of these four pillars. So Stefan, I'm going to turn off my webcam. You can turn on your mic and please walk us through these four elements to achieve total quality management.
Yeah, so hello to everyone. So we are going to see how we are first starting with what we call monitoring. So we can go on the next slide. So monitoring is a matter of, first of all, connecting all the data sources together where you can have potential events which can lead to, let's say, investigation or non-quality. And from all these events, you will go that you are going to capture, you need to do triage, and then you will do investigation, because when a problem happens, of course, the first thing that you do as a human, you try to figure out what happened, and you try to figure out what similarity situation you had in the past from which you can learn, and you will go so step by step and get to the root cause. But to do this event capture, of course, what you will see that you have in general a lot of data coming from operational data. And this information, of course, you will have to support it also with production and business related data, because everything that you will capture from non-quality events, no matter if it's in manufacturing or in the operation, you will have to loop it back into your processes. So for that, you will connect the dots, and most of the information that you will capture in real life will come from different, let's say, operational systems like manufacturing, operations management, IoT data sources, maintenance systems, CRM systems, even from the net or any other data sources. And all these systems, you will first have to connect them together on a common referential, because probably you're not talking about the same product or the same situation with the same vocabulary and the same ontology in these different pieces of application. So having a way to get everything on a common referential is really the first step, which is important to do. But then, of course, once you have captured the event, what you want to do is to see how you can link it back to the order, the manufacturing order, the purchase order from your customer, the design, the supply chain, because there might be here some relevant information that will be needed for you to do this investigation. And that's where we are going to connect, in addition, of course, let's say the IT-related transactional systems together. This will increase, again, the visibility on what we call the common referential. So here, we have mostly connected everything together, and this will feed what we call our 3D experience twin that has been presented just before, and that will help you to collect and understand the knowledge and the know-how about what happens and how you can solve it. From there, of course, what you can do, then you can go into the investigation phase, where you can look at anything in any system, no matter where the information is coming from. And the interesting thing here is that you are completely disconnected from the application. No matter where the data source is coming from, you have everything on one hand and the fingertips from one user interface, from where you can do this investigation, look for similarities, root cause analysis, and then of course collaborate, because technical problems are very often have to be solved with different types of expertise. And so collaboration is key. And at the end, as we said, we need to decide quickly, because of course, when it's in operation, you need to solve the problem, and the time is money. And as we said, as having the access to all these data sources will help you to figure out quickly what's happening. So what we are going to show here it's one application where a manager can have an overview of the different issues that have been raised from different sources. It can be a claim, it can be an issue coming from manufacturing, and what he will see is that when having a new problem that occurs on the shop floor, or coming from a non-conformity, or coming from a claim from a customer, he will be able to look at the different figures and eventually raise an investigation request for a technician to look at. So now, if I'm jumping into another role where I'm a support engineer, I can, from my user interface, get the notification from a manager that I have received this investigation request, for which I will have to look at the problem that have been raised by a customer who sent a problem with one of the equipment he's using in operation, for which he had an issue. So the support engineer will be able to take the context which have been captured with the non-conformity or the claim, so that he can, here in this particular case, look at the configuration of the system that has a problem, and from there, what he can do, thanks to the machine learning that will look for similarities on the same type of problems, he will be able to look through a heat map, trying to figure out where and what could be the reason of this failure. So he will see that thanks to the clustering and the concentration of defects that have been analyzed by the machine learning or across all the different systems that are under maintenance, he can see that there are different, let's say, parts of the subsystem that pops up as being, let's say, a major cluster which can lead to a problem. Here, what he figured out, that the problem is probably related to one of the sub-equipment, because there are more, let's say, complaints related to this type of system than other parts. From there, even without having to go into any other external system, he can look at similar complaints that happened in the past and figure out through the analysis that finally there are some commonalities with here the flexible that we can see here with the pictures which have been taken by the maintenance people, and it seems that there are really some recurring problems. Easily, what he can do is see this concentration of errors directly on the representation of the digital twin of the equipment, and see that finally the problem might be related to some parts which are all potentially at the same location. So there might be an issue probably with one system that is either oversized or that might have some problems. So here it can even go further and do an investigation and look for the engine that is pushing the pressure into the tube, and see that finally on that system for that given asset, looking at the IoT data, he see that the prediction system gave him some warning that there might be potentially some issue with some sub pressure that happens on that particular asset. So that will help him to see that there might be a problem. Looking further, what he can do, he can also see that over the time there might be some problems with some other things, and he can directly have access here to documents which are testing and inspection reports which have been written by different technicians on the field, and the analytics give him directly again through the machine learning the most recurring problem that might lead to a problem. From there, the technician can start to open what we call an investigation dossier that you can see here on the right hand side. So he's filling all these findings, and he can go and look further into the system for additional data. Then what he will do, he can also go and switch onto the web and see for a particular supplier, directly looking on his website, even from the same user environment, if there are not any parts for which some other people have raised some issues, and so he can go further and see if either the problem is not related only to this type of system or maybe to other systems, and at least also he can decide what is the best action to do what needs to be replaced, what is the most efficient spare part he should take, and action that he should be done to repair and to correct this action. So from there, he can directly launch the action and take the decision to close the issue. And so we can see very quickly that from one place, without having to know anything about the source of the data, knowing where the customer is, what are the type of document that have been reported by different people, he can really have access to everything. And because of the massive amount of data, he has a support of machine learning, which helps him to get directly access to the most relevant information that is will help him to investigate. That's really what we call the control cockpit, from one place you can directly investigate. Then of course, once you have figured out what happened, you will have to go into what we say the quality execution. Here, quality execution, of course, is something that has to be executed at different places. It's what we call a closed loop activity, because of course you need to react fast and solve the problem quickly. We might also need to do curative action, and in particular maybe also ask for some derogation. So here we have an example where it has been defined that finally the issue happened on the shop floor, and we can see that through an application that can be directly used by any operator or field worker using a mobile device on the field. He can directly use the work instruction that will be present on the screen to help him to do the recognition and the definition and feeding the system with what he found on the field. Here, for instance, what we see again, it's a very important point. When it comes to non-quality, most of the time it's very difficult to explain what is a non-quality problem. And here we do a combination of using the 2D or the 3D elements, which helps the user or the field worker to explain directly by pointing on the system where he has seen what. And as we can see here in the description on the left-hand side, we can suggest to the operator or to the field worker to enter specifically the reason code of what he has seen on this particular place. The interesting point here is that all the information that we capture will be recorded in a term of digitalization, so that we can then later on do investigation and heat maps on it, and we can also see exactly from a visual standpoint what effect it has on the product itself. So when it comes to the final inspection, especially when you are on products, that might be very interesting. But nonetheless, once you have entered some issues on a product, you don't have just one product on the field. You might have hundreds or thousands of products. And what is very interesting and important at the end is to figure out through heat maps if you have not a concentration of type of errors at some particular place or on some particular items, so that you can figure out maybe that you have a problem in your design or in your supply chain, or maybe it's a problem of a shipping or transportation where you have always a crack at the same place. So it might be related to the way the system has been sent to the end user. And this again is an important point, because when you look just on a defect from a single standpoint, you cannot take any decision and see really if it's not a problem which is more general to a process or to an organization, or something that you need really to reshape or revisit in the way that you are doing. And this is again something which is very helpful, because thanks to the analytics, you will see where are your priorities, where are the weaknesses, and where you need to act or react more faster than for some other problems. Then, of course, once you have fixed the problem, you might also have to define and decide if, from a reactive standpoint, you need to do something on what we call a short loop. So here we are not on a closed loop anymore, we are on a short loop, but you need to be able to determine if the problem that you have encountered, you have fixed it, okay, but you need to see if there is not, let's say, a non-conformity that you need to fix in a more, let's say, deeper way. For that, what the quality engineer will do, he can create what we call a non-conformance resolution item, on which he is going to enter all the different elements that will help him to explain and to describe everything that have been reported on the field. Again, when I talk about the field, it can be in manufacturing, it can come from after sales, and he will determine the specific, what are the different actions that have to be taken, what are the people that will be involved to analyze and investigate this non-conformity, and linked all the different documents together so that everything is bundled in one place. And thanks to the workflow, you will determine who has to do what at one moment, and you will promote the workflow step by step. And you can see here that using this, let's say, process, you can easily follow a non-conformity process that will lead to do investigation, and at the end, a quality engineer and the team will define and decide if this non-conformity will have to raise or open what we call a CAPA process, because it means that you need to do really some deeper investigation to correct the action on the design or even on the engineering side. So now what we have seen, of course, that once the reactive quality has been solved, that we have seen here typically that we have been able to collaborate without getting out of the platform. We have increased the productivity because you've been able to involve many people, having everyone access to the right information on the right place, and have with the right speed to correct and to react, and to be really agile, because everyone will receive the notification to do what he is supposed to based on the context, without having to look in many places to find the information. He really everyone gets access to the information with the right visibility, so that then they can act and react quickly. So proactive quality here, it's about saying now we have figured out that we have something to change in the design, because the problem that has been raised by the different defects or issue that we have seen has to be transformed into a project that we are going to drive, so that we can solve the problem and change our design. So this process that we see here is really compliant with APQP, let's say, procedure, and you can determine here for your product exactly step by step what has to be done, so that you can really analyze the failure modes, because you know that upfront in the design for any part, any system or product that you are designing, you define all the failure modes and effects and the root causes that might have to be, let's say, captured, so that you avoid to have the problems. But as we have seen, if you have problems in the real life, this problem will be used, look back into the FMEA system, so that you can see where you have to improve a case. You will have to add a new case, check the requirement that have been given initially by the design engineering, or that you can look with your customer ultimately who gave you the specification, so that at the end you can really trace from the specification and the user requirements from functional safety standpoint what you need to do, how you need to act, and what you need to enter as a new case to prevent a new problem, the problem that you have seen, so that you can correct it as early as possible in your process by adding a new case. And this allows you again here to have really the full understanding of what was the problem, why you have not been able to track it, because you see that in your initial FMEA, it was a case that was a potential, let's say, failure that was not identified at the very beginning. Then you can, of course, qualify this failure mode with severity and classify it, give the occurrence of problems, the potential cause of problems, link all the documents together, so that when you have an audit and you need to specify or qualify why and what has been done, and justify, you have all the information in one place to explain it with the full traceability and the full audit capabilities. go to the next slide. And so finally, when you look at the global picture, what about the quality activities? Here we have, as we have seen, we have this corrective and preventive actions, where from one corrective plan you can define really who are the different stakeholders who will be involved, what are the steps they are going to follow, what time it will take, with which resources, and which type of information is needed to do the investigation, so that you have access to the audit documents, the origin complaints, specification of the equipment, non-conformity that have been described, requirements, so that you have really everything together in the same context, so that you can then drive your root cause analysis using the type of Ishikawa diagram, so that you can see if it's a problem of people, of product, of process, of material. That's really the investigation that helps you really to go to the 5 whys, which is ultimately the best way to figure out how you can solve a problem. And then of course you will monitor and track that thanks to this workflow, where you will track the process, the activities step by step again, to make sure that everyone who is involved in the process of correction and investigation will contribute to it in the right way, on the right place, and you will be able to capture everything. At the end, of course, what you will have to do is a risk analysis, because we know all that when it comes to a problem of quality, as there is always, we have seen a trade-off between the risk of not correcting something and the risk and the effect it can have if the problem has not been solved. So this will help you really to do this risk assessment and make sure that you have not missed anything according to the policy you have, the quality engagement you have with your customer, and moreover the health and safety that you have to track and to also to comply with. At the end, of course, all this is something that happens in, let's say, in real time, and at the daily level. You can also imagine that in big organization you will have hundreds and thousands of activities that you will have to monitor. So it means that ultimately at the end you will have to have some KPIs, so that you can track really the different projects, because here we are talking about projects that helps you to do better and to correct these different issues over the time, and that helps you again to drive the change and make sure that you're on the right track. So finally, what we have seen here is that at the end, finally, the quality is a matter of doing an improvement loop, a continuous loop of getting the issues from the field, the one that you have not been able to identify upfront, and to be able to understand what's happening, to collaborate, to react, to be agile, and to have all the consistent elements to do these activities on your daily basis in your organization, across your plans, with the different disciplines all together, without having to, let's say, exchange information through Excel, through mails. And that's very important, because when it comes to quality, of course, we all know that people have a lot of IT system and operating system, which are most of the time designed to follow what we call the happy path. And when you have a problem, of course, it's something which is unforeseen. And when you have an unforeseen problem, it's difficult to figure out what happened, because you are normally, all the process have been defined and designed not having a problem. So when you have a problem, then it becomes difficult to investigate. And that's where this end-to-end quality control tower will help you really to be sharp on your activity.
Thank you, Stefan. That is comprehensive. You did a nice job summarizing and highlighting the important elements of that. And you covered a lot of stuff. I mean, if I just go through those 4 areas, I mean, that whole first part on this, you'll call it the control center, where you're going to take smart decisions because you have all the information in context, in the right place, live, real time. You have the ability to capture the things and do the closed loop controls right at the point of failure based on inputs. You've got the short feedback loops, the non-conformances corrections with the standardized flow to make sure that the right things are being done. And then, of course, when it is needed to move into the proactive quality, whether it's a full-blown DFMEA or a PFMEA for process, to try to understand, hey, I'm not on the happy path. How do we resolve this? Do we need to create new requirements? Do we need to then connect it to the changes that are needed, whether those changes are design changes or manufacturing changes or documentation changes or process changes, whatever they are, you're being able to put that all together. And ultimately having all of this in one place brings this ability to have this 360 view, that everyone is connected and able to enforce and share and collaborate wherever you might be in this steps of quality, with the analytics available at every time. And this whole process becomes embedded everywhere. And then because we are in every industry, and because these projects and processes are tailorable, all of these tools, whether they're specific quality tools, whether they're more analytical tools, and certainly all the collaboration, all of the actions, are all there and can follow whatever the standards are dictating across those industries. And that's because at the end, as I mentioned before, we can achieve total quality management, because while yes, we do have the quality governance and we have the elements to capture the information, we can then see it in context. We can connect it all the way back to the twin to do the design FMEA and the process FMEA, or even use that to do what if scenarios. Hey, if I've got to change my factory and deal with COVID and social distancing, do all that planning, and how does that impact quality? How does it impact timing? And then capture that data and check your findings virtually, implemented in real. So that real-time stuff, you can have that agility and actionability because you have all the information connected in one place. And for those areas where those quality events are happening in disparate systems, that's where we can start to connect them. So connecting the virtual and the real. So all the operational data where you have the where and the when things are happening, to connect it in for decision making around the why, right? Then being able to share that on the how are you building this thing? So the know-how that's involved in putting that together and connecting all these pieces together, which of course influence how then you may maintain proactively, reactively, be more intelligent there. So the what and the who, capturing, did these things happen? If they did it improve operation? Or if we change a design or change something for its better manufacturability in the field, you have all of these things that you can now do, and you can do more and more and more of those right in the platform with the dedicated specialty apps for people to do that. And then as we talked about, these root causes or things coming right in, or the sources of the stuff could be from a customer claim, so pulling all that information in as it's being experienced. And also Stefan showed the ability to go and capture out in the real world, the social networks, the information, the news feeds, it could be new regulations, it could be all kinds of things that you're able to bring in to help you make better decisions, make things right, fix them, and get to this first time right mentality, which becomes now a culture of differentiation rather than, hey, we got to reduce cost and it's an operational thing. It becomes a strategic element of what you're doing. And this is, again, what we talk about total quality management. Now you involve everybody across every place where value is being created. So people doing the upstream, doing the planning, getting all those inputs and information to help plan to do the right thing. But then that doesn't always go, right? So we want to make sure that you have the assurance that the people doing the work are doing it right and having those processes in place to govern those things. And then when you manufacture, you're checking the things that are done, were they done right? And then having all those elements there to capture and then connect all those elements. And then of course the perception out there, that sales, do you have some things happening that look like, maybe they don't have a defined quality thing yet, but you're starting to get those inputs in there. And then of course all the real data coming from ownership, whether it's complaints or issues, IoT data, all this type of stuff, to then do it better next time. Fix the issue, but then do it better next time, and connect all of this together with quality at the core, not as an afterthought, built in. This is what's going to give you total quality management. This is what's going to bring you extreme quality as a competitive strategic advantage. It's a DNA of an enterprise. So this is where we're getting at. But before we get into any questions you guys might have, I did want to ask Stefan, okay, this is excellent. We can connect all these things. The data is there, the analytics, the context, the collaboration, actionability. Where do you see this going even further? What's next?
Good question. What's next? The next is, in fact, as you know, we all dream that quality would never be a problem, meaning that we would never encounter any issue. Now what we are doing is, of course, we are taking advantage of the analytics and the machine learning and big data, data science in general, and what we are working on, and it's really in a good shape, is to say that based on all these events that are happening, we will ask the algorithm to learn from these events, to figure out what happens, to do it for us, because we are all lazy and we prefer the machine to work for us. But more seriously, the important point here is that thanks to the big data that we have, the more data we have, the more the algorithm can be trained. And by being trained, this algorithm will be able to figure out upfront what might happen, and it will help us to change our business processes so that the issues will not happen again anymore. And this is really something which is interesting, because it means that we will do a kind of reverse engineering of the processes so that the system will help us to find the best path to make right the first time, rather than having to look at the investigation. The system will do it for us upfront.
Excellent.
So this continuous improvement will be really automated somehow.
So to get to this age of really computer support, recommendation, and actionability, again, having this quality system, taking the first steps to not only have a control system and a process and collaboration and get access to that data, but then start to put these algorithms into place to really change the game longer term. So that's pretty cool. I'm going to ask the question that's probably going to come up, but how far in the future? Is this like 10 years from now? Or is this something that is already starting to happen?
It's already implemented in some of our products right now. We do it already in the supply chain with leveraging similarities on 3Ds to help procurement to buy the right things, to find the right spare parts, and we have it in our quality asset quality intelligence to look for similarities in semantic documents, because we all know that people have no time to read a lot of documents. So we have a lot of machine learning which help us to show us directly the relevant information, and we are working on the next steps to do it with complex event processing, so that the system will be able to figure out directly on the live data what is happening, and show us what we should do as a best recommendation. So it's a continuous release process.
Excellent. So it's already there. I mean, this is impressive. So thanks, Stefan, for all that great information. We're just scratching the surface here in this short time we have, but I'd like, if you guys have some questions, you can type it into the Q&A panel there. This is being recorded. We will make the replay available. Thanks again, everyone.
Thanks. Bye.
So